All right, so let's dive into some of these. Chapter 15, this is on equilibrium, practice problems. So we're given a reaction and we're given a K value. And we want to know, we're manipulating this reaction and we want to find what the new equilibrium constant would be. So the first thing that I like to do is figure out what did we do to this reaction. So the first thing I can see is the reaction has been reversed. And now the rules say that when you reverse a reaction, you invert the K value. So I'm going to put that as 1 over K. And when I write K, I'm referring to this K. And I also notice that the reaction has been multiplied by 2. And the rules say that when you multiply a reaction, you raise the K value to that power. So our new K value is going to be inverted K, and then we're going to quantity square that, or if you prefer to write 1 over K squared. Now let's plug and chug. 1 over 2.2 times 10 to the 6th, and we'll square it. How you put it in the calculator is up to you. I'm going to invert it, and now I'm going to square it. Let's round. 2.07 times 10 to the negative 13th. K values do not have units. Makes things easy. Here's another, predicting the equilibrium constant. This is the first reaction. So think back to when we did Hess's law. This is the target, and we're going to need to manipulate these two reactions to get this one. And then we're based on what we do, instead of finding a delta H, we're going to find the K value. So let's look at this. And there's a CO2 on the left, but CO2 is on the right here. So this one is going to need to be reversed. Now, you know me, I have to rewrite them, because that's just how I am. Some of you can do this in your head and just write -1 and inverse, and I'm a bit jealous, but you know, that's okay. S plus H2O gas. Okay. So now that I've rewritten that, since I've reversed the reaction, I need to put 1 over 1.0 times 10 to the 5th as the K. All right, so now let's check this out and see how we're doing. Okay, so I have CO2 nowhere else. Okay. Next, I have 3 H2s, because there's one in each of those. I have CH3OH. And then these carbon monoxides cancel out because there's one on the left and on the right. And then I have, and just confirm that that matches, and it does. So now remember, the rules say that when you add reactions, you multiply the K values. So K1 is going to equal 1 over K2, because I reversed that reaction, times K3. So let's do that. So let's say 1 over 1.0 times 10 to the 5th times 1.4 times 10 to the 7th. If you're really good at exponents here, you would say 1.4 times 10 to the 7th over 1.0 times 10 to the 5th. You can probably do this in your head, but if you can't, let me show you on the calculator. Divided by 1 times 10 to the 5th. So if you do this with exponents, you would get 1.4 times 10 squared, or normal people call it 140. Now let's also do this next series. We want to know when Kp equals Kc. So there's an equation that says Kp equals Kc times RT to the delta N. What we care about here is delta N. So delta N is going to equal your coefficients of products minus reactants. So you can tell here Kp equals Kc when this whole term is 1. How do you make this 1? You raise it to a 0 power. So what we want to know is there are moles of products and equal moles of reactants. Now you have to be careful here because the tricky part is, remember when you're dealing with heterogeneous equilibria, solids and liquids don't count. Okay, so make sure you mark out your solids. So here on the left we have 2, and on the right we have 1. Those are not equal to each other. Here, mark out your solids. We have 3 and 3. All right, so 3 equals 3. So that one does happen. Let's check the other one. Mark out the solid. In this case, there aren't any pure liquids, but that helps. 0 does not equal 3. So the second one is the only one that would count on.